Hi and welcome. My name is Abdulrazak, and I wanted to share with you today a short video about my senior project, which was entitled with developing a mobile application that analyzes baby crying using deep learning techniques. Inside this video, I will provide an accessible introduction to deep learning and this application in baby crying analysis. And I hope that this video will cover essential parts of my project and in this rapidly advancing field of deep learning and baby crying analysis. This is my table of content. I will skip the introduction since I covered that already. So I will start giving you information about the dataset first, then preprocessing, feature extraction, feature selection, inference cry classification, model juicing and architecture, and finally mobile application and its functionality. My dataset information were as follows. In total, it contained 961 audio files and 7 seconds of each of them. And in terms of classification, it has 5 different classes, which are belly pain, pain, discomfort, hungry, and tired. Of course, yes, the dataset is not highly enough to train a model from scratch. This where transfer learning came to rescue and facilitates to our model layers to learn from pre-trained layers instead of random initialization. The main tasks in pre-processing stage are denoising and audio segmentation. The complication of the recording environment leads to unclean event cry signals. Besides event cry signals, there could be many kinds of sounds, such as footsteps, adult speech, air conditioner sound, alarm sound, and etc. So cleaning up recorded data at the pre-processing stage is a crucial step. In pre-processing, I made some denoising, which removes the background sounds. I applied high-pass VIR filter to remove the speech sounds and low-frequency noises. I have extracted features from the audio using MVCC spectrogram. This was a crucial step for audio classification related tasks. And as you can see, these two figures right now, they seem completely different. One for adult speech and other for an infant cry. The first one seems to be continuous, while the other infant cry audio has gaps in it. And apart from that, they also have a lot of unseen features that differentiate each other. There are also some potential algorithms for extracting audio features. After attempting most of them, I concluded that MVCC is best for my specific use case. And as you can guess, in feature selection, we are not working with all the features extracted from the audio because of maybe the redundancy of the feature or due to the computational cost. So I get rid a lot of unnecessary features from the extracted feature. As I said it before, I'm not going to build a model from scratch. Instead, I take advantage from transfer learning. Here are some familiar machine learning classification algorithms that may be useful for this kind of tasks, but I use CNN with transfer learning. YAMNet is a pre-trained deep learning model developed by Google Research that specializes analyzing audio events. The model has been trained on vast amount of audio data, included wide range of sounds from different categories, and it's capable of detecting various audio events, including baby bursts, screaming, and many more. I used YAMNet pre-trained model, and I also used YAMNet as a cry detector, as I will show you later on the model architecture. The model will take 15K audio data, and as you can see, it has some reshaping and some preprocessing in it. In general, the model has different kind of CNN layers like convolutional, maxi Boolean, average Boolean, fully connected, and skip connection layers with ReLU and softmax activation functions. And in the last layer, we expected the model to output two models, one for the YAMNet model, which contain 521 classes, and the other for custom model, which has only 5 classes. And as I mentioned it before, I used YAMNet as a cry detector, since YAMNet model can detect crying and similar audio events like screaming, bursts, baby crying, And the logic for cry detecting is simple. If YAMNet model didn't predict input audio to be one of the cry similar classes, it will be dropped and our custom model will not be triggered. This will help us our model not to make predictions every single audio. So we reached the final part of our project where I would like to show you the mobile application architecture and functionality. First of all, the application has two functionality. Either you can record audio from scratch or you can import it from your local device. I will 100% recommend you to record audio since imported audio might get affected by the model requirement. The model requirement are as follows. As you can see here, the audio should be mono and have sample rate of 16K and also should have extensions of WAV, extension of WAV file. Since extension is like MP3 are compressed using compression algorithms and it will be mispredict if you violate the requirement. And that's why I recommend you for recording audio from scratch.